Alright guys, this is video 1.6. Today we're going to be talking about midpoint and distance in a coordinate plane. So the midpoint formula, and this is for use in a coordinate plane, is going to be if you have a segment AB and M is the midpoint, if the endpoints of A, we're going to give them the designation x1 and y1, and B is x2, y2, then the midpoint is going to be taking your two x coordinates and taking the average of them. So you would add them and divide by 2, and then also with your y, and that will give you m. So let's try it. So we are going to find the coordinates of the midpoint of CD if the endpoints are C is -2, -1, so that would be -2, -1, so C would go right here. And D is at 4, 2, which would be here. So if we connect those with a line, where's our midpoint? And you could eyeball it and say, oh, it's got to be right here, but that's not good enough. What we're going to use is the midpoint formula to find the coordinates of our midpoint. So remember, our midpoint formula, we want to take our x's, add them up and divide by 2, and our y's, add them up, and divide by 2. So here we go. My x2, it doesn't matter which one, I'm going to say 4. So we're going to go with 4 plus -2 divided by 2. And our y's would be 2 plus -1. Go ahead and put those in parentheses. Divided by 2. So 4 plus -2 is 4 minus 2. So 4 minus 2 divided by 2. That's going to give us 4 minus 2 is 2 divided by 2 is 1. So our x value is at a 1. So our y value here, we'll have a 2 plus -1 is 2 minus 1 divided by 2. 2 minus 1 is 1 divided by 2. So our y value is at 1/2. So our midpoint is going to be at 1/2, which is about where my graph showed that it should be. What we know is that since it is the midpoint, that it bisects segment CD. So we know that this line is congruent to that line. So you can also use the midpoint formula to find the coordinates of an endpoint. If you have one endpoint and a midpoint, then you can use the midpoint formula to find the other one. So what we have here, if we were to graph this out, is we have A is at 2, 2, and we have M at 4, -3. So this is just half of it, right? So here's M and here's A. So B is somewhere down here. So we're going to find the coordinates of B. So what we're first going to do is what we're looking for on B, we're just going to say that is an X and a Y. Okay, so we're going to name the coordinates that we're looking for. The next thing is let's go ahead and set up our formula here. So we know that our coordinates here are 4, -3 for our midpoint. And we know that that will be equal to x2 plus x1 over 2 and y2 plus y1 over 2. Right? So what we're looking for is the x and the y. So what I'm going to do is I'm going to replace my x2 and my y2 with my coordinates of point A. Okay. So, and then what I know that this needs to be equal to 4. So the way I'm going to rewrite it is I'm going to say 4, because that's what my midpoint equals out to, is equal to my x coordinate from A was 2, so 2 plus x divided by 2. And my y is going to be equal to -3. So I'm going to say -3 is my y value, 2 plus y divided by 2. Now the first thing that we need to do to solve this is to get rid of this fraction that is happening here at the side. So the best way to do that is to multiply this whole side by 2, which means I'm going to multiply this side by 2. So 2 times 4 will be 8. What happens when I do this is that my 2's will cancel out and become a 1, leaving me with 2 plus x. Isolate my x by subtracting 2 from both sides, giving me 6 is equal to x. All right, same thing on my y. I'm going to multiply this by 2 and this side by 2, giving me a negative 6 is equal to 2 plus y. Isolate my y by moving my 2 over, giving me negative 8 is equal to y. So this point right here should be at 6, negative 8. Now, given that the slope of that line, and here's 4, 5, 6 would be about right here. And then 8 would be down 1, 2, 3, 4, 5, 6, 7, 8, approximately. And so it should continue on in a line showing that that is part of a segment. If you've gotten a point that was way over here, then that can't possibly be the midpoint of this segment. Does that make sense? So it should be able to make logical sense that it is following in the correct direction. The other formula that you need to know is your distance formula. So the distance between 2 points on a coordinate plane is going to be the difference between your x values squared and the difference between your y values squared. Then you add those and take the square root. It's going to be a lot of steps, but you'll be able to get it done, I promise. So let's find A and B, or AB and CD, and then decide if they are congruent. So the way we'll know they're congruent is if they have the same distance. So we're going to use the distance formula twice here. First, we're going to do AB. All right, so we're looking for the distance of AB. So A is this point here, which is at 0, 3. B is here, which is going to be at 5, 1. So let's go ahead and do that out. So I got the square root. I'm going to take my x's and subtract them. So I'm going to say 5 minus 0 squared plus 1 minus 3 squared. So PEMDAS says I need to solve what's inside my parentheses first. I'm going to keep my square root there. 5 minus 0 is 5, so that would be 5 squared, plus 1 minus 3 is negative 2, so I have negative 2 squared. Next in PEMDAS says we need to do our exponents. So I'll have a 25 plus 4, which is going to give me radical 29. Just going to leave it just like that. Let's look at CD now. Our point at C is a negative 1, 1. And at D is negative 3, negative 4. All right, so I'm going to take the square root of the difference of my x's, which would be negative 3 minus a negative 1, which makes it a plus 1 squared, plus my y's. I'll have my negative 4 minus 1 squared. Solve what's inside my parentheses first. Negative 3 plus 1 is a negative 2. And negative 4 minus 1 is a negative 5. So now I have negative 2 squared, which will give me a 4. And negative 5 squared, which will give me a 25. 4 plus 25 is square root of 29. Okay, so their distances are equal. That means that segment AB is congruent to segment CD. The distance formula, the way they get it is related to the Pythagorean theorem, which we will work with a whole lot more in another chapter. But for now, you can think of another way of doing the distance formula. If you look at this as being the segment, this line right here as being the segment, what you can do for the Pythagorean theorem is you just make a triangle out of it, a right triangle. It only works on a right triangle. C is always the hypotenuse, which is going to be the long side, the side opposite your right angle. The measure of C is you take A and square it, plus B squared, and then to find what C is, you would take the square root of that. So you can see that it's A squared plus B squared equals C squared. So if you're looking for just the distance of C, then that would be the square root of A squared plus B squared, which is very similar to your x squared and your y squared. So if you can see the difference between your x value here and your x value here is the distance of A, right? So you would take this point minus this point to get your distance of A. And the same thing with your b. What your b is measuring is your change in your rise, your y value in your coordinate plane. So your Pythagorean theorem can also be useful in finding distance, and the distance formula is derived from the Pythagorean theorem. So if you have trouble remembering the distance formula, if you can remember a squared plus b squared equals c squared, you can get there and get the answer for the distance. When you come in tomorrow, make sure that you're able to find the coordinates of a midpoint, find the coordinates of an endpoint, find the distance of a segment, and then to determine whether two segments are congruent. Have a good evening.